Hello everybody, welcome to the first of the climate change videos. There are going to be 3 of them altogether, and I thought it would be sensible just to start with a reminder of what you need to know. I won't stay on this slide for too long, but obviously those of you that I teach, you can access this on OneDrive. So you can just print this out if you'd like to. Basically, you need to know causes, impacts and responses, which is a fairly typical set of notes for geography, to be perfectly honest with you. I just want to really explain one key thing, and I probably will repeat this so many times you'll be fed up of me telling you. For your exam board, you only need to know about the anthropogenic greenhouse effect, the fact that humans are producing more greenhouse gases, which is leading to the earth warming up. You do not need to know the other natural causes because they happened historically. They're not particularly relevant now. But I am going to teach them to those people who are interested. So I will make it really obvious which bits of the video you can kind of skip over and ignore if you would like to. This video then is going to all be about causes and some key ideas that you need to know. The second video will introduce you to impacts. You could do a full degree or possibly, spend your whole life studying the impacts of climate change. I'm going to introduce you to them and then suggest that you pick and choose which ones you focus on because you cannot know them all. So that will be video number 2, and then video number 3 will be what on earth are we doing about it? And we have to look at a range of scales for that. Okay, so for climate change, there's loads on the internet. There's loads everywhere, isn't there? You can't move for mentioning climate change, really. These are some of the best, in my opinion, at the moment. You may disagree, and if you would like to tell me of others or better ones, that would be lovely. But there are just a few trailers there. Sorry, that was very American. A few, I can't even think of the word now, but anyway, you get the idea. Right, what's your task for this? You need to take some notes from this video, please. If you've got your module booklet, climate change begins on page 70. So we're right at the back of the booklet now, and you are very welcome, of course, to jot your notes in the module booklet or just grab yourselves a piece of paper. So you need to know that climate change is not new. When I taught you coasts, one of the things I go on about is that sea level rise and fall is not new. We tend to think that it is a modern thing, but it's not. It's been going on ever since we've had a planet, and that's the same with climate change. But what's different is the cause. Historically, climate change has all been natural, and now it isn't. It's anthropogenic or human or enhanced. There's lots of different words we can use. So climate change is not new, but the cause is. Okay, that's a really important idea to get your head around. You only need to know for this exam board cause number 5, which is greenhouse gases. You can skip the others if you would like to. But you do need good notes on greenhouse gases because it's the one cause that you have to know. You need some definitions, and you need some examples of feedback loops. Now, we've talked about feedback loops a lot in physical geography, and we will have a little revision opportunity at that point, but you need to have a couple of examples of feedback loops in climate change, okay? Everything else that I talk about is purely for interest. It might, obviously I'm biased, I would say watch all of it and maybe just don't take notes on those bits, but that's up to you. I will make it obvious which bits are purely for interest. Okay, so that's your task, please. So here is my pretty basic graph to tell you that climate change isn't new. We have had warmer periods that we call interglacials. We've had colder periods that are either called glacials or ice ages. It's not new, and you may be aware of some children's animated movies that are all about this, and actually, do you know what, you probably could watch them and claim relevance at this point. Climate change is not new, okay? The climate change has got warmer and colder for millennia. We, in this A-level, have to know a little bit in coasts about the last ice age, because in the last ice age, everything that's white on that map is what we think was ice. Obviously, we don't have Google Earth to prove this to us, but we've got some evidence. More on that in a minute. So where the white is, we think was covered in ice. Where the brown is was land at the time, because of course there is this thing called eustatic sea level change, where if the water is locked up in the ice, it can't be in the sea. So we have this fluctuation. So there's a lovely synoptic link here between the coast module in year 1 and climate change in year 2. Now, how do we know that? If we didn't have Google Earth 21,000 years ago, obviously, how do we know that the climate's changed? So this is not crucial for this syllabus, but I do personally think it's quite interesting. We have what's called proxy evidence, and the most likely place that you will encounter the word proxy in the English language is with voting. So when you get to the age of 18 in the UK, you can vote. And sometimes you're not able to physically get to a polling station on voting day. And as it says there, you might be away. I remember for the infamous Brexit vote, my husband was at Glastonbury Festival and he gave me his proxy vote so I could go to the polling station on his behalf. People might physically not be able to get there. You might be on a tour of duty with the military, whatever. So proxy is kind of indirect. You vote, but you do it via another person. And we have what's called proxy evidence of climate change. It's not an actual temperature. It's not, you know, a satellite photo, but it's indirect evidence. It's stuff like this. Width of tree rings. Trees have wider rings in good growth years and narrower rings in not very good years. That can help you think about climate change. You can have historical records, so paintings or tax bills or various kind of, in more recent times, newspaper stories, etc. Ice cores are probably the best, so you can take these cylindrical cores from the thickest ice sheets of the Arctic and Antarctica, and they can tell you loads. I would, at one point in the geography A level, have had to teach you oxygen isotopes, but they're not particularly relevant anymore. But they are really helpful, probably one of the most unbiased sources of evidence we have. So, climate change isn't new. The cause is. How do we know that climate change isn't new? It's something called proxy evidence, okay? And there are various types of it, but don't get too bogged down in it. Causes. Remember, the first 4 of these you don't actually need to know for this exam board. You can skip to number 5, greenhouse gases. But as I said, my personal opinion would be listen to the first 4 anyway. But that's my opinion. Right. So, climate change isn't new, but this time it's unnatural. Why did climate change happen before humans turned up and ruined everything? Okay, we know about these things. We've studied these. Volcanic eruptions. So, volcanic eruptions can produce massive ash clouds, which of course block out sunlight. We've talked about that a little bit with Pinatubo. We've talked about that with Laki in Iceland. But yeah, absolutely, volcanic eruptions have the power to block out sunlight and cause climate change. In the past, and I think the geologists have to know this, there have been massive volcanic eruptions. So on either of these maps, on the left-hand side, the brown, and on the right map, the red, that is the size of the lava flow. Massive lava flows. And they think that it's quite possible that lava flows of that magnitude would have released so much CO2 into the atmosphere that they would have led to climate change. Now, can I just say, if you read anything on the internet that tells you that the CO2 increase in the atmosphere now is the fault of volcanoes, leave the website immediately, okay? I think it's been calculated on an average year, volcanoes produce less than 1% of the carbon dioxide that humans do. Volcanoes have definitely the power to change the climate, but we cannot blame what's happening now on them. So they can cause cooling because of ash clouds and warming because of CO2. Volcanoes absolutely definitely capable of climate change, but not now. That you can't blame them. It's ridiculous. Meteorites. Okay, we're kind of into extinction of the dinosaur theory stuff. Well, some people would also talk about volcanoes. Meteorites, they sometimes hit the Earth, occasionally with disastrous consequences. So if you look at the map, it gives you some kind of scale of the, I've never pronounced this possible. I'm going to go with Chicxulub, which is probably terrible. You can get a sense of how big that meteorite was compared to the size of the countries around it. Massive, great big thing. When that hit, it would have created the most enormous cloud of debris and water and soil, and it probably, the theory is that the cloud of debris and dust created by the impact of that meteorite would have blocked the atmosphere, much like a volcanic ash cloud, but on a much bigger scale, and would have blocked out sunlight and led to climate change, and possibly led to the extinction of dinosaurs and other things. Okay, so meteorites, volcanoes. Here's the probable reason. And unfortunately, these are quite complex. Can I remind you, you do not need to know these for your syllabus, but they're just quite interesting. Okay, Milankovitch, Czech scientist, physicist, I believe, who worked out that, yes, of course, the Earth orbits the Sun. We all know that, but it varies in 3 different ways. So the orbit can be circular, or it can be quite elliptical, and the variation between those two he calls eccentricity. We are currently tilted at 23.5 degrees, but he's also calculated that sometimes we're slightly less tilted and sometimes we're a bit more tilted. And because that's to do with angles, it's called obliquity. And then I think this one's brilliant. It's basically the wobble, ladies and gents, and I'm going to show you a little YouTube in a minute that will help you understand what I mean by the wobble for precession. Now, some people watching this are just going to be horrified at what I'm about to tell you, because I am going to ridiculously oversimplify it. And the reason I'm going to ridiculously oversimplify it is because it isn't actually that crucial for our exam board. If you're watching this and it is, can I suggest that you watch someone else's video, because I am going to simplify it quite significantly. So let's think of the sun as our heat source, because that is what it is. It's where we get our heat from, okay? If you think about that as being the fire in your house, or the radiator in your bedroom, or whatever, a source of heat that you have at home. The closer you are to that source of heat, the warmer you are. The further away from that source of heat you are, the colder you are. Yeah, that kind of makes sense, doesn't it? So what these 3 things essentially mean is that you can be receiving more heat from the sun or less heat from the sun. Okay, so that's basically what Milankovitch cycles explain, and they work. But those of you that have to know them properly, I think possibly that's true for geologists, each of these is on a different time scale. So sometimes the 3 of them will overlap, and they will mean that the sun is kind of the Earth is receiving maximum possible insolation from the sun. Sometimes the three of them will overlap so that the Earth is receiving the tiniest amount of insolation it possibly can. And sometimes they'll kind of cancel each other out. So one of them will be maximum and the other two will be minimum. And what he predicted is that basically those cycles would at least partly explain the temperatures on Earth. Now, that's not a perfect correlation, but you know from your geography coursework that perfect correlations are very unlikely. And that's it. Now, most people will tell you that all of the historic climate change on Earth probably can be explained by Milankovitch cycles, and significantly cleverer people than me have worked on it and agreed it to be true. So they're probably a key part of it. Now, according to Milankovitch cycles, we should very slowly be heading into an ice age. But actually, we're going hotter and hotter and hotter, which is why we think that humans have caused climate change. Now, I promised you more information about the wobble precession. I am going to open this, which is about, excuse me. It's about very cool things called gyroscopes. They are just fab. And I'm going to skip. It might be helpful to you to watch the whole thing. That is what I mean by the wobble. Okay, so because the Earth spins, the wobble changes. Now, luckily, ladies and gents, that stage never happens with the Earth. We haven't quite wobbled and collapsed on the ground or in the middle of the Milky Way, thankfully. But when he puts it down,
it stays vertical.
Notice it wobbles. So it would wobble closer towards the sun or possibly further away. Okay, now watch the whole of that if you would feel it's helpful, because I've got it there for you. Oh, hang on, let's go back to... There we are. Okay, so they're a bit complicated. Can I just remind you, not crucial, okay? Interesting. Now, the fourth one, they think that Milankovitch cycles are responsible for the majority of climate change, and then the amount of insolation received by Earth kind of affects ocean circulation first. And that basically acts as a catalyst. So it will either really speed up the cooling or it will really speed up the warming process. So the idea is that, yes, okay, Milankovitch cycles probably explain the changes in the amount of heat we receive. They get exaggerated by the thermohaline circulation. These are our deep ocean currents. And then anything that can't be explained by Milankovitch and the ocean currents is probably an anomaly caused by a volcanic eruption or a meteorite impact. So those four have kind of worked together for history. Right, that's the optional bit finished, okay? According to Milankovitch and everything, we should now be getting colder. That's not happening, and it's not happening because of these things. And bottom of page 71 of your module booklet is where you start to get some information. Notice there is a pretty good correlation here between the amount of CO2 in the atmosphere and what the temperature was in Antarctica. That is sort of pretty undeniable, isn't it, really? Okay, first things first, and this is written at the bottom of page 71, and it is really, really important. I can't emphasise this enough. You will find textbooks, websites, essays telling you that the greenhouse effect is a terrible thing, and you have to be really careful, because the greenhouse effect actually is essential for life on Earth. If we didn't have it, the average temperature on Earth would be -18, okay, which is about the temperature of your freezer. We need some greenhouse gases. We need the greenhouse effect. But what we've done is we've enhanced it. We've added more greenhouse gases, which trap more heat. And that's the problem. Okay, so I can't emphasize enough, getting your head around the difference between the normal greenhouse effect and the enhanced one is pretty crucial. Why is it called the greenhouse effect? Well, greenhouses, which are actually made of glass, called greenhouses because they're usually full of plants. But anyway, the whole point of greenhouses is to trap heat. If you look at this thermal image, you can clearly see that the greenhouse is much warmer than the surrounding places. That's why it's called the greenhouse effect, okay? That's where the name comes from if you're interested. And the greenhouse gases are listed in your module booklet. They are carbon dioxide, methane, nitrous oxide. Now there is a fourth, which is water vapour. The reason we don't really talk about water vapour is because the amount of it is more to do with natural processes than it is to do with people. So you can kind of push water vapour to one side. Carbon dioxide, methane, nitrous oxide. Now page 72 has got some information about where those gases come from. And this is a really, really perfect opportunity to be synoptic because you can link this to fossil fuels and the carbon cycle. You can link this to agriculture, which is a primary sector activity, changing places. You can link it to all sorts of things. So read page 72. Either do a little bit of highlighting or possibly take the key ideas and put them into your notes. It would also be a fantastic idea to go onto this website and update the ppm of CO2. So if I'm reading page 72, it says, and I'm quoting, pre-industrial levels of carbon dioxide were about 280 parts per million by volume, and current levels are greater than 398. Well, actually, we're pretty much on 414 near as damn it. Okay, so it's a good idea just to check what that is telling you so you can have the most up-to-date figures possible. Okay, so more greenhouse gases in the atmosphere, that causes global warming. You just need to know that that's what that phrase means, okay? Nice and easy, to be honest. There's a very famous graph, not crucial for us to know, but the hockey stick graph kind of sums up what's happened. If you plot temperatures, they're sort of, obviously they go up and down, of course they do, but they fluctuate around a norm, and then at the end, they just go up, exactly like an ice hockey stick. Global warming is real, it's happening. All of the evidence, I could bore you with slides and slides of evidence, but I'm not going to do that. Every single data set we have is telling us that the planet is warming up. Okay, there is no scientific evidence that is telling us the opposite. I'm sorry to tell you. Global warming is happening, folks. So, a couple of other key ideas that you just need to know. You need to know what the word forcing means. And forcing is a nice, easy one. Anything that makes, or if you like, anything that forces the climate to change, you could refer to as climate forcing. That could be greenhouse gases, it could be a volcano, whatever. But climate forcing, just in case it comes into an essay question, is anything that makes the climate change. Tipping points are a little bit trickier to explain, and I have to confess that when I first taught these a couple of years ago, I had all these weird analogies, and a student very gingerly put their hand up and went, "Do you mean like the game tipping point?" And I was like, "What do you mean the game tipping point?" I had diddly squat idea that there was a TV programme that was perfect for what I was trying to explain. If you've seen it, you'll understand what I mean. I was using the 2-penny slots from amusement arcades. Some of you might be, braver than me and go for the 10p ones. I'm very definitely a fan of the 2p version of that. Right, what on earth is it? A tipping point. So a tipping point is the point beyond which everything changes. Everything kind of, goes wrong. So, like you're putting your 2p's in, aren't you? Or your 10p's if you're feeling rich. And you're putting them in and nothing happens, nothing happens, nothing happens. And then all of a sudden you'll put one final coin in and you'll get this cascade effect. That's what we mean by a tipping point, okay? The point at which a series of small changes becomes significant enough. It's a little bit like me losing my temper, There'll be a series of small little things that irritate me. And then there'll be a point where that's it, I've lost my patience. And and that's it, I've lost my temper at that point. Whatever analogy you need, you need to know a definition. Now, because I'm not brilliant at explaining tipping points, as you can tell, I have included a couple of websites there that you are very welcome to use in case you need somebody else to explain that to you. And these kinds of things, I do not need you to learn all of them, but they are things that if they happen, it's all gonna just get worse from that. If we lost the Amazon rainforest, we don't really know what would happen after that, do we? But it would definitely be a tipping point. Everything would be different after that. If we lost the Arctic sea ice, it's all going to change after that point. So maybe just learn one or two of those that you could literally drop in as name drops of this is a tipping point, this is a tipping point. But we will actually talk about these more when we get to the impacts lesson. Right, nearly finished. The last part of this first video is a nice bit of revision, I hope. So, in physical geography, we talk a lot about systems. Systems have inputs, outputs, stores, and processes. We talk about them in the water cycle. We talk about them in the carbon cycle. We talk about them in coasts. It's a really important idea, and the one thing that we really emphasize is if you change one thing, because systems are interconnected, you will then have knock-on effects on the rest of that system. Well, that kind of is what tipping points are, so it all links nicely together. The point that we get confused is that negative is a good thing and positive is a bad thing, and that's like, what? No, that doesn't make sense in my head. And I get that, and I don't really have a shortcut for how you learn it. You're just going to have to remember its opposite. Negative feedback reduces change. It's how your body regulates temperature. So when you get too hot, you start to sweat. Your face goes red because all the blood is being sent to the skin so it can start to cool you down. You might start to pant. Your body is working really hard to cool you down, and it does exactly the same in reverse if you get too cold. Negative feedback reduces change. It's trying to maintain equilibrium in the system. Positive exaggerates the change. It makes things worse, okay? Now, krill pooing. This came up in the carbon cycle, and basically krill is pretty much the bottom of most food chains in the ocean. And because of that, it tends to hide away, krill hide away where they're not quite so obvious, but they swim up to eat plankton near the surface of the ocean once a day. They would then swim back down and poo. And what they're basically doing is they're storing carbon at the bottom of the ocean, which is excellent. So the carbon gets photosynthesized, so it gets taken out of the atmosphere into the plankton. The krill eats it. Now the carbon's in the krill poos. The carbon is now stored at the bottom of the ocean. Amazing, brilliant. They used to eat and poo once a day, and they're now eating and pooing much more frequently. They are really helping us out. Amazing. There's some evidence, but I've put 4 question marks because it's very kind of in its infancy. There's some evidence that we're seeing more volcanic eruptions, and that might be because volcanoes are mountains and they tend to have ice and snow on top, that as the ice and snow melts, there's kind of not so much of a lid on top of the volcano. I know that's a terrible analogy, but you know what I mean. There's not so much pressure, and therefore we're seeing more volcanic eruptions, which produce more ash clouds, which block out sunlight and cool the earth down. Are volcanoes trying to help us out? It's too early to tell. So we've got a couple of good, but I'm sorry to say we've got loads of bad ones. All you need is I'd say an example of each, okay? If you really want to show off 2 examples of each, but an example will be fine. We've talked a lot about albedo. Pale colour surfaces reflect insolation really well. If you lose your ice, you lose your pale coloured surfaces, so actually less sunlight is going to be reflected out to space. That's not good, is it? So that's bad. Melting permafrost comes from the carbon cycle. Permafrost means permanently frozen, and there are loads of bogs in Siberia and Russia and many other places, but famously in Russia and Siberia, that are full of dead organic matter. Now, it hasn't been decomposing very quickly because it's been frozen. When things decompose, they release methane. Earth warms up, bogs thaw, methane is reduced. That is terrible because methane is significantly worse in terms of its greenhouse effect than CO2. You don't hear about it so much, but it is much more powerful as a greenhouse gas. So we're really worried about that. And in fact, look, it comes up here in a climate tipping point. As the Earth warms up, we should see more evaporation and evapotranspiration, shouldn't we? Well, I mentioned a while ago that water vapour is a greenhouse gas. We don't tend to mention it because humans don't really significantly directly affect it, but that could be a problem. And we're seeing destruction of the tropical rainforest for a whole load of reasons. We're going to talk about this in impacts. But one of the reasons we're losing the rainforest is climate change. It is not just deforestation, although that's all part and parcel of the same problem. And obviously, one of the brilliant things that the rainforest does is takes in huge amounts of carbon dioxide via photosynthesis. If we don't have a rainforest, then we're not going to have that issue. They're often referred to as the lungs of the earth, the rainforest, because they take in CO2 and produce oxygen. Yeah, it's a bit depressing, isn't it, ladies and gents? And for that, I apologise. So I'm going to leave that slide up to finish because it is a bit confusing what you need to know and what is optional. But that is it for video number 1.